Hello dear students, so now today we would move ahead in this first chapter of class 12th mathematics, that is relations and functions. So here have a new question for you. Question is the following relations is defined on the set of real numbers. Again the relations has been defined on the set of real numbers, that is R. Okay, so now the first question has been given here. A is related to B if and only if the condition is A minus B is greater than 0. Okay, if it is following if the two elements are following these two the condition here, then only you would say that the given elements are means having a relation here. Okay, so this condition it should follow now. Okay, now we would check whether the given relation is reflexive or not. So let's check first its reflexivity. Okay, now if you see let's say we have an element that is a real number. We have a real number here, and now let's say we are saying, let's say A is related to A, let's say. Okay, because the given relation would be reflexive if and only if A means the element is also related to itself also. All the elements of the given set of the given relation are related to itself also, then only you would say that the given relation is reflexive. Means the doublet of all the elements are there, isn't it? So it implies that we can say that let A is related to A. So does it follow this one condition? Let's see, A minus A. Because if A is related to A, then I would write here A minus A should be greater than 0. So is it greater than 0? Is it greater than 0? It would come equals to 0. So what I would say, I would write here, if A is related to A, this does not imply that A minus A is greater than 0, because A minus A is not greater than 0. So hence I would say that the given relation is not reflexive. Hence the given relation is not reflexive, isn't it? Okay, now we would check whether the given relation is symmetric or not. Okay, now let's check it's a symmetric, where it's a symmetric or not. Okay, now the given relation is symmetric. Okay, for that we would take two elements. Let me write here, let A is related to B, and one more element I am taking B, sorry, and B is also related to A. B is also okay, only this much let me write. Let A is related to B. Now if A is related to B, this relation is there in this relation. Okay, so there is a relation between the two elements. So it implies what? It should follow this one condition. It implies A minus B is greater than 0, isn't it? Okay, now does it also imply that B minus A is also greater than 0? Can I write it? No, never. Because A minus B greater than 0, it implies that A is greater than B, isn't it? But if I am writing B minus A greater than 0, so it does not imply that B is greater than A, because A is greater than B. That is why you are getting the positive answer. But if you are writing B first, so you would be getting the negative answer, because B is smaller than A. So you would be getting negative answer. So it does not imply that B minus A is greater than 0. So it does not imply that B minus A is greater than 0. So if B minus A is not greater than 0, then I would write here B is not related to A. So it implies B is not related to A. Okay, so hence what? Hence the given relation is not symmetric, isn't it? Okay, now we would check whether the given relation is transitive or not. Okay, so now let's see whether the given relation is transitive or not. So let's check transitive. Okay, now for that I would take two elements, so rather I would take just three elements. Let's say A is related to B, and B is also related to C. Let's say B is also related to C. Now A is related to B and B is related to C. So what does it imply? If A is related to B, it implies that A minus B is greater than 0. And if B is related to C, it also implies that B minus C also greater than 0, isn't it? Now let me tell you now. If A minus B greater than 0 and B minus C is also greater than 0, so can I write A minus C is also greater than 0? Is it correct? Just tell me. See, a minus b greater than 0 means a is greater than b. Okay, and b minus c is greater than 0 means b is greater than c. It also implies that a is greater than c, isn't it? If a is greater than c, then a minus c would be positive, so would be greater than 0, isn't it? So I can write a minus c is greater than 0. So this implies that a minus c is greater than 0. Now if a minus c is greater than 0, so it also implies that a is related to c also. Okay, so hence we have proved if a is related to b and b is related to c, then the first and last means a is also related to c here also. So hence R is transitive. Okay, so just note it down. Then after we would move towards the next question. Now this is the next part of the question. Question is a is related to b if and only if the condition is a plus 1 plus ab is greater than 0. Then only you would say that a is related to b. A would be related to b if and only if 1 plus ab is greater than 0. Okay, now we would check whether the given relation is reflexive or not. Okay, so first check its reflexivity. Now a would be related to a, so let me write here, let a is related to a itself. Let me just write here, let a is related to a. So what does this imply? According to the given condition, if a is related to a, it implies that 1 plus a into a means a square is also greater than, should be greater than 0. So does this follow this one condition? Yes, 1 plus a square is greater than 0 because let's say is negative. Let's say a is negative. So if it's a square you are doing, again you are getting the positive answer, and you are adding 1 there, you would be greater than 0. You would be getting greater than 0. So hence, if we are writing a is related to a, so it is following the given condition. So hence I would write here, hence relation is reflexive, isn't it? Because the doublet of the elements are there. We are taking any elements, so its a doublet is there in the relation. Okay, so if doublet is there in the relation, means a is related to a itself, so hence it is what? Hence the given relation is reflexive. Okay, now we would check whether the given relation is symmetric or not. Symmetric. Okay, now if you see, let me write here, let a is related to b, so it implies that it should follow this one condition. If I'm writing a is related to b, so it should follow this one condition. Condition is what? A plus 1 plus ab is also greater than 0. So just tell me, does it also imply that 1 plus ba is also greater than 0? Yes, only the order I have changed here. If 1 plus ab is greater than 0, so this also implies that 1 plus ba is also greater than 0. So if 1 plus ba is greater than 0, then I would write b is also related to a, isn't it? Hence, it also implies that b is related to a. Now if a is related to b and b is related to a, so hence what? Hence the given relation is symmetric, isn't it? Hence R is symmetric. Okay, now let's move ahead towards transitive. Okay, now we would check whether the given relation is transitive or not. Now if you see, for that we would take 3 elements. Let's say a is related to b and b is related to c. Now if if a is related to b, so it implies that the condition is 1 plus ab should be greater than 0. Now, and if b is related to c, this implies that 1 plus bc should be also greater than 0. So now just tell me, can I write 1 plus ac is also greater than 0? Can I write this? Can I write this? For that we would take some values there. Let's say b is 0, a is 1 and c is minus 1. Let's say these are the values here. Now one by one put the values. Now if you just put these values here, 1 plus a b is 0, a is 1, so 0 into 1 1, so 0 into 1 0, so 1 plus 0 is 1, greater than 0. Yes, it's correct. Now just put this value here, 1 plus bc, 1 plus b is what? 0 again, c is minus 1, so again you would be getting 0, so 1 is there, so 1 is always greater than 0. Okay, now put the values here. 1 plus a is what? 1. b c is what? C is minus 1. Now if you just solve this, you would be getting 0. So can 0 be greater than 0? Can 0 be greater than 0? No. So hence, if you are writing that 1 plus AB is greater than 0 and 1 plus BC is also greater than 0, so this does not imply that 1 plus AC is also greater than 0. Hence it implies that what? It implies A and C are not related, means A is not related to C. Okay, if A is related to B and B is related to C, then first and last means A is not related to C here. So hence the given relation is not transitive. Okay, hence R is not transitive. Okay, just note it down. Now we would check whether this given relation is reflexive, symmetric, or transitive or not. Okay, A is related to B if the condition is mod of A is less than equals to B. Okay, now we would check first its reflexivity. Okay, now for that we would take the doublet there. Okay, now let's say A is related to A itself. Let A is related to A. So if I'm writing A is related to A, so it should follow this one condition. It implies that mod of A less than equals to A. Mod of A less than equals to A. So is it possible? Just tell me. Let's say your A is minus 2. Let's say A is minus 2. Okay, just put the values now here. Mod of minus 2 less than equals to minus 2. Mod of minus 2 is plus 2. So can this plus 2 be less than equals to minus 2? Can it be possible? Just tell me. Can it be possible? Mod of minus 2 is 2. So can I write 2 is less than equal to minus 2? No, never, because 2 is always greater than minus 2. So how can I write this? So hence this is not following this one condition. So if I am writing A is related to A, so modulus of A is not less than equals to A. So this does not imply this. Okay. So now if it does not imply this, so hence you would say it also implies that A is not related to A. A is not related to A. Hence R is not reflexive, isn't it? Okay. Now move towards the symmetric now. Whether R is symmetric or not. Okay. Now if you see symmetric. Okay. So for symmetric, let's say I am writing here A is related to B. Okay. Now if A is related to B, so it implies what? It implies that the condition is A modulus of A should be less than equals to B. Isn't it? Okay. Now does it also imply that modulus of B is also less than equals to A? Just tell me. Modulus of B can be less than equals to A. Let's say for that we would take the example. Let's say A is 4 and B is 6. Now put the values here. Let's say A is 4 and B is 6. Now put the values here. 4. If you just put the values here. So in the first one, it is modulus of 4 less than equals to B is 6. Okay. Now we see modulus of 4 is 4. So 4 is always less than 6, isn't it? So yes, it is right. It can be less than and it also can be equals to also. But we have taken similar elements. We have not taken the similar elements here. 4 and 6 different elements we have taken. Now if you see 4 is always less than 6. So this condition is being followed here. Now whether this one condition is being followed or not, just put the values now. Mod of B, that is mod of 6 less than equals to A is what? 4. Mod of 6 is 6. So can 6 be less than equals to 4? No, 6 is always greater than 4. We cannot write this, isn't it? So hence if I am writing A is related to B, so it implies that modulus of A is less than equals to B. So but it does not imply that modulus of B is also less than equals to A. So if it does not imply this, so what does it imply? It implies B is not related to A. So now if A is related to B and B is not related to A, then you would say that the given relation is not symmetric. It implies the given relation is not symmetric, isn't it? Okay. Now we would check whether the given relation is transitive or not. Transitive or not. Okay. Sorry, what was the question here? I think it was the third question. Yeah. A is related to B if modulus of A less than equals to B. Okay. Now we would check whether the given relation is transitive or not. Okay. So for that we have to take three elements. Let's say A is related to B. Okay. And B is related to C. Now what does it imply? If A is related to B, so it implies that condition is what? Modulus of A is less than equals to B. Isn't it? And if B is also related to C, then it also implies that modulus of B is also less than equals to C, isn't it? Now we can write that modulus of A less than equals to modulus of B, and this modulus of B is what? This is less than equals to C, isn't it? Can I write it in this way? Yes, because modulus of A is less than equals to modulus of B. Whether I write B or modulus B, same. So if modulus of A is less than equals to B, and modulus of B is less than equals to C, so we can write it implies that modulus of A is less than equals to modulus of B and is also less than equals to modulus of C. So we can write modulus of A is less than equals to C. Can we write this? Yes, because modulus of A is less than equals to is less than this also and this also. So we can write modulus of A is less than equal to C. Now if this is so, A modulus of A is less than equals to C, so we can write A is related to C also. So it implies A is related to C. Now if A is related to B and B is related to C and A is also related to C, then what does it imply? It implies that relation is transitive. Isn't it? Getting it or not? So that is all for today. Now we would be discussing some more questions in the upcoming lectures. Till then, stay tuned and keep watching. Thank you. Have a good day.